In my last video talking about artificial intelligence, we looked at what makes up an artificial neural network. And we took a look at artificial neurons or perceptrons. And in this video, we're going to address how an artificial neural network actually trains and how it actually learns. So we have the basic structure, the layers of perceptrons, and now we're going to look at what a full artificial neural network with multiple perceptrons actually does in order to learn and how it learns from its mistakes. So to start, let's take a look at a simple model or simple artificial neural network that we have here. We have 3 perceptrons in the first layer, and we have 1 perceptron in that final layer that will be producing the output. And we will look at what output looks like when it comes from an artificial neural network. And in this example, we will be looking at image classification. Here's a picture of one of my dogs, one of my parents' dogs. Her name is Ruby. She's a golden doodle. I know she doesn't really look like one, but she is. And my parents have 3, and she is personally, don't tell the other 2, but she is personally my favorite. Anyways, I digress. So we're going to look at common features of a dog face that we use to readily identify dogs. So we've got the eyes, and we will put those into the top neuron. We've got the droopy ears, and we will put that into the middle neuron. And then we've got the nose or the snout, and we will put that into the bottom neuron. Now, in the real world, we don't manually assign which attributes are applied to each perceptron. They decide that themselves, and it's randomized, and it's usually not just one perceptron, one neuron that is responsible, but a collection of neurons that look at each individual feature of an image. So with each feature mapped to its perceptron, we can do some math to produce output for this artificial neural network. And just a brief recap for those who didn't watch the last video explaining how information is fed into a perceptron. Information always enters a perceptron or a neural network in the form of numbers. That is how computers read information. And a good example of this, at least in pictures, is that a picture is a whole bunch of pixels. And one pixel has a combination of red, green, and blue values. And those values range from 0 to 255. So in a red pixel, an all red pixel, we could say it would have a red value of 255 and then a value of 0 for green and blue. And those values in the eyes, ears, nose, and whatever other features we choose will get multiplied by a weight. Now, the importance of weights is to help the next layer or the next perceptron determine the importance of each of the preceding perceptrons. So in this example, we are going to say that the eyes, ears, and nose are of equal importance in determining the output for this neural network. So again, we will multiply those pixel values by their weights, and we will add up all of those values to determine the output. And the output in this case is just going to be whether or not this is a dog. So yes, this is a dog. Great. Our neural network has produced correct output, and it's working as we hoped it would. But what happens if we now have a picture of a different animal, of a cat? This is one of my cats. His name is Oliver. I am a cat and a dog person. I do find that cats are a little bit easier to take care of, and being a college student and working and making YouTube videos, I do find that cats are just a little bit easier for me right now. So just like how we looked at the key features of a dog's face, we're going to be looking at the key features of this cat face. We have the ears, eyes, and nose. And again, we're going to map that to their respective perceptrons. It's going to be the same order as the perceptrons in the dog picture because this is the same neural network. And we're going to take those values, again, multiply them by their weights, and feed them into that final output neuron, which is going to say, hey, yes, this is a dog. But wait, it's not a dog. So in this case, our neural network has produced incorrect output. Now, how do we teach our neural network that this is actually not a dog? Or how do we make it so it can make better predictions or better output in the future? Well, what we do is we take that error and we feed it back into the neural network. So we go backwards in something that is called back propagation. So again, we take the error, we say to that final neuron, hey, this is wrong. And then that final neuron sends it to its next neurons and says, hey, we were wrong. What are we going to do to make a better or to perform better in the future? And this happens by way of changing the weights. So, for instance, with the image of a cat, or with cats in general, cats have those very distinctive cat eyes. So maybe the neurons or the network decides that eyes are probably a little bit more important with determining whether or not this is a dog or not, or a cat or not. So we're going to raise that value up to 2. And maybe we say, some dogs have pointy ears. The last dog had droopy ears, but ears on dogs kind of vary a lot. So maybe they're not as important because we can have dogs that have ears similar to this cat. So we have those updated weights. We have a new neural network with updated weights. And just a side note, in the real world, it's not so easy and so quick. It usually takes many, many, many what we call generations to update the weights to find a good performing neural network. And so again, with these new weights, we're going to feed it back into the neural network and it's going to say, wait, no, this is not a dog. And that is correct. We now have a properly functioning neural network.